Hello everyone, good morning. I want to continue on the revision. I will try to keep this as short as possible because today it had to be a very busy day, okay, for the classes. Some of your companions have exams, so I'm trying the best that I can to have everything ready for you. So please try to follow up with me. I will try to go through this as quick as possible. Here, this is a version of, as I told you, the final exam. This is really very important. You have to read everything carefully. Try to be on time. Try to sleep well before your exam. So if you sleep well, you study before you came. Try to be on the campus as early as possible because I want you to feel comfortable about being before your exam starts. Try to get all the stuff that you need. Try to get your pencils, pens, stuff like that. This is normal and you will need it. So it has to be with you. Okay, identify the version of your exam on the first page of your answer booklet. Just write it, which version you are. Write your name, student number, and the group. Of course, I will need the ID. I'm talking about discipline ID for the Cairo campus students. Don't answer to more than one group per sheet, so every question should be answered in just only one page. Don't unstable the answer booklet, it's not your right, you have to keep it stable. Okay, always provide a careful justification for all your conclusions, except group 1, group 2, specifically for this exam. Okay, for the first group, it's a multiple choice question. So it's identified the way it's going to be assessed. As you can see, identify the answer booklet, only correct answer will be considered, minus 1.3 grade, and an answer not given, for 0 for any answer is not given. The wrong answers, you will have a penalty of 0.3. The first question states that, and the grades are written over here. It's just only 1 mark out of 20, and it's about linear transformation. In the first session, I've told you that you will have to review all of your course materials to be ready for any pop-up or any question that needs. So I will start by reading this question carefully. For the linear transformation T such that it's from R3 into R2, it is known that for the vector double 1, negative 1, after you do your linear transform, and also for T double 1 and 1, the result will be 3 and negative 1. So this is mainly the answer for these two vectors, which is 3 by 1, and it will be 2 by 1. As you can see, it's a transformation, translating stuff from R3 into R2, which could be transformation matrix of T. This is the statement, or this is the head of this question. And he's giving you these 4 alternatives to choose which is the best solution to just go through it. Okay. Once he's giving me such a question, I will have to review in my mind where did I hear about a linear transformation or something like this. Once you remember that, it will lead you directly that you know in a linear transformation, a T for an X, it will equal to A times X. So now I'm searching for the matrix of A, which could be any one of these 4 matrices. Once you reach this point, it will come up to your mind that it is really makes sense that once you try to solve a system of equations or this question, you will need to have a matrix 2 by 3, because if you multiply by the column matrix, which is 3, the result will be a 2 by 1. So this is mainly what I want you to remark. Let us consider the linear transform, which is the A matrix 2 by 3 times the 3 times 1, which will equal to a result of 2 by 1. So all I have to do is to search for a matrix 3 by 2 that will justify this condition. Okay, here we go. This is the matrix. I don't know which one of them, so I will just try to put any numbers. So I'm considering A, B, C, D, E, F. This is the transform of the first vector, which is 1, 1, and negative 1. The result will be 3 and negative 1. Once you look at it from this point of view, you will be able to know also that I've given you, or there is also another condition that I'm giving to you, which is that same transformation for the second vector, which is triple 1, which leads me to a system of 2 equations in 2 unknowns. It's a 2 equations, in 3 unknowns. So all I have to do is to try to write them down. It's really very simple. Just try to multiply the first row by the first column, same way like, and you will end up having something like this. So if I try to do this multiplication, you will have, for this, it's gonna be A, B, C, D, E, and F, and then you will try to multiply it by 1, 1, and negative 1. Doing this multiplication will result, and it's equal to the value of 3 and negative 1. This is 3 and negative 1. If I want to do this, it's really very simple. Just multiplying, so it's going to be A plus B minus C should equal to 3. Doing the same thing, but with the second row, will drive you to D, as I told you, plus E minus F, which is supposed to equal to negative 1. If I used the second condition, which states that when you multiply by triple 1, it's going to be the same. So this one is going to be positive, so you will have another equation, which is A plus B plus C equal to C. These are 2 equations in 3 unknowns. Once you try to add these 2 equations together, so if I have A plus B minus 3, A plus B plus 3, this one, minus C, and this is plus C, this is equal to 3, and that one also equal to 3. So adding them together will lead to in A plus B, 2 of them equal 6, which means A plus B equal 3, that's an equation. The second one will lead to C equal to 0 once you try to resolve. So I'm searching now for one of these choices with the sum of the first 2 elements equal to 3. So I will neglect choice number A, and I will neglect choice number D. I'm between B and C. Which one of them is going to be the correct? It will happen by trying to solve this equation with the other equation, which states that D plus E plus F equal to negative 1. Once you try to solve it exactly like this one, then you will have your condition. So once more, as I told you, trying to expand these 2 equations, you will end up having the first row times 1, 1, negative 1 equal to 3. So this is for the first equation. Multiplying also A, B, C times this column will equal to 3. This is the second one. Trying to solve these 2 equations together will give you C equal to 0. That's A plus B equal to 3. So I can, as I told you, choose it's either B or C. If I did the same with the second row, so I will end up having F equal to 0 and the D plus E equal to negative 1. So I will look to these 2 equations. D plus E should equal to negative 1. So this is not the correct answer. This is going to be the correct answer. As you can see, we started step by step, going through everything step by step. Then you will get what you want. For the second question, he's giving you a determinant, which is as given. As you can see, this is what is the determinant of this matrix. Knowing that he's giving you a condition that's A, B, C, D, which is one of its minors, equal to negative half. This is really very simple. All I have to do is to try to choose the largest number of zeros that exist in a row or a column. So first of all, I will remark that the first row contains 3 zeros. So I will go ahead and use Gauss method to expand the determinant of this matrix, but using the first one. So the first row signs will be positive, then negative, so it's a negative 2 times, remove the first row and remove the row and the column, and you will have negative 2, okay, let's do it. You will have negative 2 times a smaller determinant, which starts with 0, C, and the A, 0, C, and the A, then 7, 11, 17, and also you will have 0, I'm erasing this one, 0, D, and B. So this is 0, that's D, and that's B. Okay, same way like, I will try to search for the row or a column that contains the maximum number of zeros. So I believe the first row also looks tempting. So it's going to be negative 2 times a negative of a 7 because of the sign of this minor. I will try to erase the first row and first column. So I will end up having C, D, A, and B. I will try to get, I'm trying actually to reach this 4, which is A, B, C, D, because I know its value equal to negative half. And this is going to equal to 14, but I will have to change rows. This is why in the first session I told you, you will have to review all the propositions and the properties relative to determinants. So all I have to do is to replace these 2 rows instead of each other. So it's going to be A, B, C, and D. This is going to develop a negative sign. Now, taking advantage from this value and substituting here, I will end up having negative 14 times negative 1 over 2, which is going to negative 2 lead to 7. Now I can choose the right answer, as you can see. So it's really very simple, just to go through it, as I told you, with the same steps. It's really very simple. Okay, once more, as I told you, we will expand the first row of these 4 by 4 dimension. Then on the first row of a 3 by 3 of its minor, then use advantage of the row operation. For the third question, he's asking you what is not a basis for R3. Once you start talking about this part, okay, about basis of a certain vector space or a subvector space, I'm actually looking for 3 independent vectors that can generate this vector space or subvector space. So this is the standard set and it's linearly independent. But I want you to take a good care of the question. So I will read it once more. He's stating that what is not a basis for R3. So I'm not searching for a basis for R3, or on the contrary, I'm trying to search for which one of them is not. So yes, this can work. Also, that one, it will cover X, Y, and Z. So this is the X, this is the Y, and this will cover the value of Z. So also this set is linearly independent and can cover R3. Similar manner for this one, okay, because this one doesn't cover Z, this one doesn't cover Z, but this contains Z, so it will do this. But for the set in D, remark that this one 1 double 0, and that one is 0 and double 1. This is a triple 1. This is actually a linear combination between these 2 vectors. If you add them together, it will develop this vector. So number D is not linearly independent, I'm sorry. So number D is not the correct answer, as you can see. Okay, for problem number D, if 2 is an eigenvalue of A, which is necessarily an eigenvalue of A plus I. This is really a very nice question. It will depend on the definition of the eigenvalues and the eigenvector. The first statement is very, very important. So as I told you, this is a good problem. Remember the first eigenvalues definitions. So I will start with the definition. What's the definition of an eigenvalue and the eigenvector? I'm searching for a vector and the value that once you make the multiplication a times nu, it will equal to lambda times nu. Okay, perfect. So instead of a, if I have a plus I, all I have to do is just replace a by a plus I times nu, which will result nu times I, which is nu times a will be a by nu. Then, if I replace the a by nu by the value of lambda nu, okay, as you can see, if I do this replacement, okay, it's going to be like this. Then the second step will be taking nu as a common, so you will end up having lambda plus 1, and which value of lambda is given here is telling you that a is one of the eigenvalues of a. So if you add lambda plus I, as we did here, the eigenvalue will be lambda plus 1. So since lambda here is 2, so the result will be 3. This is going to be the correct answer for this question. These questions, please try to go through them very slowly. Read the question more than once. Then read the statement. Try to determine which part of your course this question is directed to. Just go through it. Start with the principles. If the answer is not clear in front of your eyes, just to remember what you were doing in that part. In group number 2, question number 2, it's a 2-mark question. He's telling you, consider a system of linear equations, ax equal b, which is a non-homogeneous system of equations, such that x, y, z, and w will equal to, which actually, remember me, with the null space and the particular solution of a system of equations. You will see this form if you have infinite number of solutions. Because I have, this is the x or the unknown variables. This is the first column which contains the values of the equations. And these are the free variables. So actually, the null of A here consists of 3. So I can put them easily on this form, which is going to be more easier for your eye to remark. This is x, y, z, and w, the column of the unknowns. This is the principal or the xp. That's k1 times 1, k2 times 1, and it's on the second row, k3 times 1, which on the third row, which stands for first unknown, second unknown, third unknown, which means you will start your solution with a 4x4 system or 4 unknowns in a number of equations, and you will end it up with a reduced echelon form into 3 equations. So actually, it's a consistent but dependent solution. I want you to remember these remarks. We really did go through them early in the morning today. So n is the number of unknowns, dimensions of null of A is the number of the free variables. This is 1, 2, and 3. So the null space here is 3. So keep it in mind. Okay. Dimension of row A is the number of equations, which seems I've started with certain number of equations. The dimension of column A is the number of unknowns. I have 4 of them. So just making a substitution in this, n, which is the number of unknowns 4. The dimension of the null of A, as you can see, we have 3 of them. So it's a 4 minus 3. So the rank of A will equal to 1. So once more, A must be a 4-column matrix, as we have 4 unknowns. Rank of A is 1, as each variable will depend on another variable. Evaluating the null dimension is 3, as I exactly told you. Of course, the null is the solution of the homogeneous system. So now I can recall the statement here. It's stating that rewrite the following sentence, filling each blank space with an integer from 0 to 100. So write from 0 to 100 for these. The matrix A has number of columns. Once you see this, it has 4 columns. and has a rank equal to, yep, it's 1, because I have 3 independent, because I have 3 free variables. As we can deduce, the dimension of the null space of A is equal to 3. Also, B is necessarily equal to the column of A, which is 4, as I told you, and this is how it's going to be completed. So, the matrix has 4 columns, the rank is A, okay? For the dimension of the null, it's going to be 3, as I told you, depending on the 3 free variables, and space will equal to. And this, now we will go through question number 3, or group number 3. This is really a very good question. It's tackling the part of solutions of a system of equations, also connecting this part with the solution, with the column and row operations and the dimensions that we did go through it. So he's starting with a very nice question, which is the augmented matrix of this matrix. Try to get the augmented matrix. Once you try to do so, please be careful that he may give you x2 instead of x1 and so on. So try to be sure that it's well arranged. x1, it's beneath each other. x2, similarly like, remember, there is no x2 here, so I will have a 0, x3 beneath each other. So it's simply just easy to put them on an augmented matrix, which is going to be 1, 3, and A, then 0, -3, and 3, then 1, 2, and 1, exactly like this. The results will be -1b and -4, as you can see. Now I will start the operations for the reduced echelon form. Actually, the answer of the first question, which is the augmented matrix already given, he is stating that classify the system as a function of A and B. This is why I will go through this process, trying to get as much as possible, as close as much as possible to a reduced echelon form. So what's going to hit into my mind is that I can multiply the first row, for example, by -3 and add it on the second row. Then I will multiply the first row by -A, then I will add it to the last row in such a way I will try to get to the echelon form. So I want you to remember, it's very, very simple. All I have to do is to open my matrix exactly like this. Then I will start with writing the first row, which is 1, 0, 1, -1 for the first row. I will multiply by -3 and add it on the second row. So it's going to be -3 plus 3, which is 0. -3 times 0, 0 plus -3, so it's going to be -3. -3 plus 2, so it will develop -1. Multiplying by -3, which is +3, plus b, so I will have b plus 3. In a similar manner, I will multiply the first row by -a and then add it on a. So -a plus a, it's going to be 0. -a times 0, 0 plus 3, so it's going to be 3. -a times 1, -a plus 1, so it's going to be 1 minus a. In a similar manner, multiplying by -a, so it's going to be positive plus -4, so you will have -4 plus a b. I'm sorry, I will multiply by a, I'm sorry, negative a, so it's going to be positive a plus -4, so it's a -4 plus an a over here. Then, once more, I will try to add these two columns together in order to get this number equal to 0, and once you try to do so, you will have your conditions here. So, I'm going to skip this step. I don't want to be long on you, you can do it on your own. And finally, I will have, this is the reduced echelon form that I'm telling you about. So what I did, I've added the last two rows in the last example. Now, for this system of equations, I will have now the conditions. Remark, this is the coefficient matrix, that is the augmented matrix. So, for the time being, I will have the debate of having a equals 0. If a equals 0, okay, in such a case, if a equal to 0, I will have a 0 over here, and I will have b minus 1 for the last row. So it's going to be like this. Now, for A equal to 0, I will have two alternatives. One of them, if B doesn't equal to 1, which means there will be no solution for this system, because you will have inconsistent system. The rank of A will equal to 2, while the rank of the augmented matrix is greater than 2. Otherwise, B will equal to positive 1. So once A equal to 0 and B equal to positive 1, you will have a consistent dependent solution or infinite, okay, number of solutions. You will have infinite number of solutions. This is what I'm going to state at the time being. So if A equal to 0, as I told you, okay, once more, if A equal to 0, okay, this is going to be the form that we are talking about. The first case, if B equal to 1, so when B equal to 1, it's really very simple that you will see that I have infinitely number of solutions. The rank of A equal to the rank of the augmented matrix, which is then the number of unknowns, and so it can be determined as I told you. For the second case, once B doesn't equal to positive 1, once A doesn't equal to 1, in such a case, I will end up having no solution, because this value is not going to equal to 0, and the rank of A is not going to equal to the rank of the augmented matrix. Okay. As I told you, the two ranks are not going to equal to each other. For the remaining questions, okay, just to go through, as I told you, the conditions one by one in the details. Okay, remaining that if A doesn't equal to 0, if the value of A doesn't equal to 0, I will have a unique solution, a consistent, dependent, independent solution, because the ranks of A and ranks of the augmented matrix will equal to 3, and this will develop a unique solution as I told you. Okay, now for C, I want to put A equal to 1 and the B equal to 0, and see what's going to happen. So I will get back once more to the main problem. Inserting A equal to 1, B equal to 0, and this is the result that I have, which leads to x1 equal -1, x2 equal to -1, and x3 equal to 0. So this is actually the solution set, which is -1, -1, and 0. He's telling you that once you do so, and the basis of R3 is given by triple 1, 1, 1, and 0, and 1, double 0. Can you get the coordinates of the solution of the system in basis B? Can you get the coordinates of this vector? Of course, because all I have to do is just to write the solution, which is -1, -1, and 0, which equal to alpha 1 times the first vector, which is triple 1s, plus alpha 2, which is 1, 1, and 0, plus alpha 3, which is time 1 and double zeros, and try to solve for alpha 1, alpha 2, and alpha 3. This is going to be the coordinates as I told you. So this is mainly the solution. And of course, using this solution and having these vectors, I can get the result, which is 0, -1, and 1, which are the values of alpha 1, alpha 2, alpha 3. Actually, if you look at this, you will find, you can remark that alpha 1 equal to 0 will remain this part. If alpha 2 equal to -1, I will have this result. So alpha 3 equal to 0, and this will lead us to the solution that's pointed in front of you. So, bottom line, just to go through each part of these solutions step by step, and try to get to the bottom of your solution. This problem is very nice. It's about the last part that we did go through, the dynamical systems, and it's very interesting problem. It's saying to you that the researcher created the following model to predict changes after studying the evaluation of political regimes for the 100 countries analyzed. They assumed two political regimes. They have autocratic and Democratic parties. Okay, XT stands for X1, which is autocratic, X2, which stands for democratic, as pointed out here. Okay, in year T, the study concludes that at each year, or in the coming year, T plus 1, it's going to equal to A times X of T, where A is 0.7, 0.1, 0.3, 0.9. Assume the original case, it was 80 to 20, so 80 autocratic into 20 democratic. Okay, according to the model, with respect to this model, interpret the entry in position 1 and 2. So I'm going to first row, first row, second column, which is 0.1. I want you to tell me what we mean about 0.1. Of course, the first row stands for the autocratic, the second row stands for the democratic. Okay, so once more, I will recall this one or this form in details. So simply, I can write the following. This is the next year, which equal to 0.7, 0.1, and you have 0.3 and 0.9, which is this matrix, times x1t, x2t, which are standing for the autocratic countries and the democratic. Once you hold this scheme on this form, it will be easy for you to see that. Look, this is for the first row, which call about the first alternatives, which means this value, 70% of the autocratic will remain autocratic. But 0.1 here stand for, but 0.1 here stand for that there is a 10% from the democratics will change and be autocratic. And this is actually what's written here. 10% of democratic countries in year T, it's the vice versa. 10% from X2 will move to X1. So 10% of democratic countries year T becomes an autocratic in T plus 1. Actually, this form explains the style of these models very good. The first one, it feeds the first alternative, either if it was the autocratic or democratic. For our case, the first row stands for the values of autocratic. So it states that 70% will remain autocratics, and there is 10% will be moving from B to A, from 2 to 1. From B to A means 10% moving from democratics into autocratics, according to this scheme. If you did go through the lecture sessions in this part, I've tried in each, starting from the lecture of this part, leading you with this matrix, which assigns the relative values for each row and each column. Okay, in a similar manner, for B, all we want to have, if we want to have B, is asking you about diagonalizing this matrix. This is really very interesting because I can get advantage of the properties of the eigenvalues that I spoke with you earlier today. I can remark that the sum of the values of the columns will come up to 1, similar to the second column, which is going to be 1 also, which leads to that one of the eigenvalues should equal to positive 1. And also, I have a trace here for the values. Okay, I can have, as I told you, a trace of this matrix, which equal to the sum of lambdas. So, I know I have a 2 by 2 system, which means lambda 1 plus lambda 2 should equal to the trace of A, which stands for 1, plus lambda 2 should equal to 0.7 plus 0.9, which is going to be 1.6. And this will lead to lambda 2 equal 0.6. Now I have the value of lambda 1 and the lambda 2. Now I know them. Lambda 1 equal positive 1, lambda 2 equal 0.6. From this analysis, now I know that lambda 1 for sure equal to positive 1 and lambda 2 equal to 0.6. It's checked. I have the eigenvalues. Corresponding to each eigenvalue, there will be an eigenvector. If you want to remember the steps, it's really Very simple. The steps of getting the corresponding eigenvalues. All I have to do is just to substitute in the system. So I will start with 0.7 minus 1, so it's going to be minus 0.3. This value is 0.1. Okay, that's the augmented matrix. Similar manner, I will have this value 0.3, and then I have 0.9 minus 1. 0.9 minus 1 is going to end up having minus 0.1. Once you try to add these two rows together in order to get as much as possible to reduce the echelon form, you will have the following form. You will have 0, 0, okay? And for the first row, okay, and for the first row, I can divide on minus 0.3, so I will have 1. 0.1 on 0.3, so I will have 1 over 3, and it is negative sign. Try to solve this form, which will lead to that's x equal 1 over 3 of a y. So for the eigenvectors, which stand for x and y, I will have 1 over 3 of y, and this is y. Then replace y by any number, 3, 1, or whatever, in order to get the corresponding value of this eigenvector. Please try to go through the lecture of the eigenvalue and the eigenvectors as I told you. If we did go through this, okay, just a second. Okay, as I told you, this is going to be the B matrix, which 1 and 3. If you try to use the second value, which is 0.6, it will develop negative 1 and 1. For our matrix, you will have 1, 3, and the negative 1 and the positive 1 with the coordinations that I've given you previously. So lambda 1 is going to be, in our case, in the model that I've solved, it's going to be 1 here and 0.6 over here. These columns will be exchanged, but I will consider this solution. This is 0.6, this is 1. And as you can see, now I can have the A matrix.